Welcome to the e-learning virtual tour about the utilization of crop residues for generation of fuel and fertilizer. You will find clickable icons and buttons to guide you throughout the tour. Please be sure to find all the items in the tour before you run out of time. This is a 360-degree photograph of the demonstration cum experimental area of waste to energy conversion initiative of Department of Energy, Tezpur University. On clicking the first icon, we will see Professor Devendra Chandra Baruah, Head and Project Investigator of this demonstration site, explaining about the usefulness of bioenergy in circular economy like biogas utilization as an energy source through use of crop residues and other organic waste materials, and overall information about the experimental area.
This facilities is for conversion of bioenergy or generation of bioenergy, and we are using some facilities for testing, number one. Second, some facilities for demonstrations so that we can convert the waste stream, which are mostly available in households, hostels, your eateries, that part which mostly is taken to the landfill or some other dumping ground. We want to test them, their potential for biogas production. This is number one. Biogas, the biofuel. And then some part, after getting the biogas, we can get them which is already decomposed but has no biogas potential but has excellent nutrients potential, crop nutrients. We are recovering crop nutrients also. I will tell you the facilities which are used for that. Second, the biogas, which has been a very this established technology, mostly the household biogas plant, traditional biogas plant. Government is given enough emphasis, particularly Indian government. Other governments also there, but Indian government since independence. But your growth and the interest are not that overwhelming that would have been. Despite that fuel is a really very critical commodity in the rural areas. Most of the families are relying on the solid fuel, having all already these particulate matter emissions and then health hazard, and then they have enough waste materials including cow dung. But the reason that what our team has identified, that technological problem, lacuna, are the main causes that people are not being fascinated or overwhelmingly supporting this system. We are doing some works to improve these biogas plants, traditional biogas plants, into modern biogas plants, incorporating IT, information technology, and IoT, the Internet of Things. Our teams are working the sensors to understand what is the operational performance of a biogas plant. Your online, which information will be available in the user's mobile phone, and then accordingly he or she will know what is the status of conversion of into their waste materials fed to these biogas plants, into biogas as well as nutrients, this other part. And then accordingly, if there are any issue, because biogas is very, very sensitive as our digestion systems. It is sensitive to the temperature, it is sensitive to the pH. pH is this feed material that we give. And so if there are anything and your intervention is required, user can intervene it. By intervening, he can maintain the maximum possible efficiency. So this is your idea. So here, these two parts of research, we are also trying to know what are the different capabilities of different other feedstocks, so that this production of biogas remains unhindered due to lack of feedstocks. I will show you what are the different feedstocks we are using here, and then what are the different facilities we have with us. So this is a 50-meter cube biogas plant. Traditionally, this biogas plant was used on this kitchen waste. The manufacturer also provided it's a kitchen waste. Around 200 kg of kitchen waste can generate 2-cylinder LPG equivalent cylinder of gas. 200 kg feedstocks I will put, and then daily I can harvest 50 meter cube. 50 meter cube of gas is equivalent to around 20 kg, less than 2 cylinders, but 20 kg of methane. Methane is LPG equivalent. So that can be used directly by connecting the pipeline to the kitchen. This is the hostel, or we can store it. We have different provisions of storing it also. This is the temporary storage in the dam itself. This is a storage. This area is a storage. You can store it here. When gas produces, it's closed. explodes.
Okay.
This is the one. And then underneath there is a reactor, your digester. We can feed it through this your holder itself. This is the feeding unit. Manually now we have pump also. Now we are using manual. We are relying on this renewable energy. We are not using any electricity because we have manpower. So we are feeding it. Once it is fed, this new fresh digested, the old digested will come through this outlet. So outlet we are not discharging to this pit. We are having a line pit and then one roof shed also. There is the purpose, two purposes. One is that the line tank will help us to get all the nutrients intact. It will not filter to this underground. And then the shed will help us to any probable ammonification or ammonia volatilizations will be prevented. We can take it. This is mostly a liquid part, slurry part. This tank has a natural provisions of separating slowly solid and liquid. Liquid part I can recirculate or again to do it, and then solid part we can again apply to this crop. We have some crops also grown over here. This is completely organic crop, or we can also store it. Then while storing, we are adding it to some other your high lignin content biomass, and then some there is a vermicompost. We are generating vermicompost. It's a very good quality vermicompost. We are generating liquid slurry for recirculation.
This is for liquid slurry.
Liquid slurry tank. No, this tank is for gas. What we are doing it now, the gas.
Those are the tank.
Those are the tank. Those are the tank, and this balloon is a gas. We can store balloon gas here. This is a simple 3 meter cube your biogas balloon. This runs about 2 burner stoves 3 hours.
This experimental site also deals with the testing of different feedstocks, primarily crop residue feedstocks. The crop residue feedstocks require manual workers. Most of the work done here are by manual workers on payment basis, which is an attempt to create employment and engagement power and provide their payment from the revenue generation. One of those works are seen in this picture where a worker is preparing feedstock for biogas production. Now, the next icon can be seen on the inlet pipe of the anaerobic digester where another manual worker is seen feeding crop residue feedstock in liquid form to the anaerobic digester. In this video, we can see workers collecting biogas from the outlet pipe of the anaerobic digester and storing it in a biogas storage balloon for use as cooking fuel. Another product of the anaerobic digester is the digested slurry, which is collected and stored in a cemented lined tank with a shed on top as shown in this picture. In this video, a worker is seen using the liquid fertilizer for the crop production, ensuring recycling of nutrients. Maintaining quality of the end product is one important requirement here, and for ensuring the quality, a standard gas analyzer is used as shown in this picture to understand the composition of the final product for the quality of the biogas. In this video, a researcher is seen using the gas analyzer for analyzing methane content and other gases. Now moving on to the next panorama, which is a lab of Professor Dhanashree Baruah in the Department of Energy, Tezpur University. We need to conduct certain experiments before taking it to the demonstration field, which are carried out in this lab. Feedstocks are pre-tested in the lab to understand its performance for generation of biogas and the nutrients. Here, a researcher is seen doing experiments on microbial culture development for maximum biogas production. This is an anaerobic bacteria maintenance jar in the laboratory. The feedstocks are tested in these bottle reactors under controlled condition before taking it to the demonstration site. The behavior of the microorganisms for different feedstocks are investigated in detail in these bottle reactors. After visiting the experimental laboratory, we will now be going to the biogas utilization area. As mentioned in the first panorama about the income generation revenue of the biogas production system, we are going to see such an attempt and one of the uses of the biogas in this panorama. The cooking fuel, which is the biogas produced in the demonstration site, is used as a proposed business model here. As you can see in this picture, it is used in a mobile eatery van which is in the Tezpur University campus. This is a mobility one, so that we can take it to different locations where it can be popularized that waste is converted into biogas and used as a cooking fuel in the eatery van. Waste to energy is also a strategy for climate change mitigation and climate smart crop management. It will be a technical demonstration for the students. This requires involvement of learners. Here, students having different courses as well as under AdaptNET are involved using this venture for demonstration of biogas in the eatery and put some food items for selling. As it can be seen in this picture, services of this mobile eatery have been demonstrated among faculty members, students, visitors, campus residents, and we have received positive and encouraging feedback. With this, we come to an end of the e-learning virtual tour.